and rich text, which is written in Markdown. And it's quite cool because it basically makes it really nice and easy to document your code in a really intuitive way, and a lot better than what you might be using in just like MATLAB commenting or Python commenting. And also it splits up your code into these different cells, which are, like, for example, this. And so you can run all these cells separately quite easily. So if you just click this, it just runs one cell, and you don't have to run your whole script whenever you do something. So that's kind of a very quick overview of what a notebook is. They're called Jupyter notebooks because they run through Jupyter, and that used to mainly rely on iPython. So I think it's going to sorry. Does anybody have an HDMI cable? I don't think it's. Yeah, it's.
I'm just going to put just turn this off now again.
No.
Yeah. Can you, is your Jupyter notebook, is that on, is that available? Did you put that on a flash drive you can use my laptop? Yeah. Or does anyone actually, let's do this. Does anyone have a Mac with Python installed that young could use? We're going to use, let's just use mine. It's just a Windows machine, so yeah.
So while we're trying to fix this, one thing that is I'll be talking about this in a second, but so Jupyter notebooks are language agnostic, so you can use them with pretty much any programming language. But the application itself is run in Python. So if you want to follow along with this, you need to install Python. And I've posted a link in the Slack channel to a distribution of Python called Mini Conda, which is quite small and nice. So if you just want to download and install that while we're getting set up. You only need to do this, obviously, if you don't already have Python on your laptop.
Oh, I just wobbled.
Maybe. Okay, I'm going to try and keep everything very still up here. Okay, cool. So just to quickly go through the benefits of using a notebook. The great thing is that you have your code, but all in the same document. So this is a Python code cell, which just prints a couple of words to the command line, to your output. But when you run it in here, all your output is displayed right in line alongside your code and obviously your documentation. And the same is true for images, which I'll show you later, and interactive code stuff, which I will try to show you later as well. And the other nice thing about using Jupyter notebooks is that you can document your code very easily, and you can share the combination of your code results and your documentation all in one file. And those render quite nicely on GitHub. So for example, this is the project that Richard is working on, and he's got all the code in this gradients notebook. And if you have that hosted on GitHub, it renders really nicely with all the documentation and even images and stuff. So that's really good about notebooks. Cool. And then the other thing you can do is you can host them interactively online. So there's some services where you just submit your notebook and people can actually use them with the code in the browser without having to install anything on their machine. And there's a website for that called mybinder.org, and I'll show you an example of that later as well, which is really nice. Cool. So after you've installed Miniconda, has everybody done that? If they're following along? The next thing you might want to do, or that you need to do, is run pip install Jupyter from the command line. So that's the CMD from Windows or just a terminal on Mac or Linux. And that will install all the necessary application files to run Jupyter notebooks. And then once you've got that, you can just type at any terminal Jupyter space notebook, and it will open the notebook application for you. Cool. So I'll give you guys a second to do that, if you guys are following along. Who's following along here? And who's got Jupyter already installed and working? Yes, to get set up with that. And maybe in the meantime, I'll also introduce some other concepts in this. So the way Jupyter works is you've got the application, which just runs the notebook for you. And then the actual code and execution of your programming is provided by kernels. And there's lots of different kernels, and there's a list of these kernels here. So these are for a huge amount of different programming languages, whatever you want to use. So for example, if you're using SAS, which you might do in epidemiology or something like that, and there's a SAS kernel, there are Ruby kernels, and Go kernels if you're trying to prepare for a job at Google. And then there's obviously also a huge amount of different Python kernels. And I think quite importantly for neuroscientists as well, there's a MATLAB kernel. And yeah, those are the ones that I wanted to highlight.
Sorry, can you put the download links for Python and Jupyter in the Slack channel, please?
I did. So
oh, you did?
Yeah, in the Slack channel, there's a link to Miniconda.
Okay.
Put that and install it. And then to actually install Jupyter, you just need to run something from the command line, which is these commands here.
Okay, great. Thanks. Found it.
Oh, cool.
So you run the thing before you start, and I'll go to Jupyter later.
Okay, yeah. Cool. Who's got Jupyter working now? Any more people? Anybody still trying to get it working?
But don't worry about it.
And then the next thing about Jupyter notebooks is that you interact with them through the web browser. And that's cool because web browsers are quite universal and everybody knows how to click on links and websites and stuff. But the other cool thing about that is you can actually run your kernel and the Jupyter Notebook app on a server and then interact with it through the web browser from your local machine, and all your code is run on the server. So if you have a neuroimaging network server, you can do that like that. Or I also have an Amazon Web Service server, for example, which you can use to run Jupyter Notebook. Cool. Okay. So if you have Jupyter Notebook installed by pip install Jupyter, and then type Jupyter space notebook in any command line, it will open a browser window. So if you've got all of it installed, try doing that right now. And let me know if anything goes wrong.
Yes.
How's that going? Okay, so once you do that, the thing that you will see first is this kind of file browser window. And this is just the introductory screen to Jupyter Notebooks, which works just like any other file browser. So in this case, I'm running all these different notebooks inside this folder, but you can then navigate to any different folder and put there. So this is just for you to navigate through your files. And to actually then start a notebook, you go to the top right corner and say New, and then you've got lots of different options for notebooks. And so if you've just only installed Python, then you'll probably only have one option for opening a new notebook. I have lots of different ones because if you have Miniconda, which you guys are installing, you can create different environments which have different versions of Python. So for example, I have a Python 3.5 kernel and I have a Python 3.6 kernel. I've got one especially for Richard's project, which has all the dependencies for that project, which is quite nice. And then I also have the MATLAB kernel installed and the R kernel installed. So if I wanted to now open a notebook in MATLAB, I just click this one. If I wanted to run a notebook with R code, I would click this one. Yeah. Yes, so unfortunately, if you want to run MATLAB notebooks, you have to have MATLAB installed on your computer, because the way it works, and maybe I don't have anywhere to draw it, but basically you have the Jupyter Notebook app, you have your kernel, which is written in Python, and then that usually runs an instance of R or of MATLAB or whatever other language you want. And so obviously to get these working, you actually need to have R installed or you need to have MATLAB installed, which is a bit of a shame, especially for MATLAB. But if you have R installed, it's very easy to then get the R kernel because you just go to this website and find the kernel you want. And so this is the IR kernel. And then you click on that, you get to this website, and then it will tell you how to install it. And so we won't do any, I'll show you in R notebook, but you don't need to do this right now. You will need to install a couple of R packages and then also install the IR kernel Python module from IPR. But yeah, cool. So if you then have your file structure and you create a new Python notebook, which I'll just use my root Python. So if you just use Python conda root on your computers, that will work. You then come to this empty notebook for an example. Is anybody having issues getting set up? Do people have Jupyter running?
No, but I'll just leave it.
Okay.
I'm just a bit lost because I couldn't figure out which version to use, and now I'm behind the curve. It's okay. Long for me to catch up.
Okay. Do you want the commands?
If you can send me that link, or just put it on Slack, maybe it is already there. I know it's more just I couldn't find that person, and now this can probably. Yeah, that'd be great. Thanks.
Cool. So I've got a Python example notebook here. And the way this all works is you've got cells, and so currently I'm in the first cell, and you can then choose whether that cell is supposed to be a markdown cell or a code cell. And you have two other options, and it's quite extendable, so there's lots of different other applications you can install that add more options to it. But the main choices, I think, are between code and markdowns. And markdown is for your documentation, and so you can then type how you want to introduce this. So and then if you run that cell by clicking this button or Control-Enter, it kind of renders it nicely. So it creates a nice little introductory cell for you. And then the next thing you might want to do is have a code cell. And so you probably want to import packages. So I don't actually just have NumPy installed in this environment, but yeah, so if you want to import a package, so NumPy is the numerical Python kind of the implementation of matrix maths in Python. You would then import that here. And then if you want to have another code cell below, you would then have that here. And in here, you could then write your Python code to run whatever you want to do. So I'm just going to do an example for loop. So if I now run this cell, it will run all the output for me. So it's pretty straightforward getting that set up. And it should just work out of the box. Have people kind of started making that book? Who's got this working? Great. Anybody else having issues? Do you have any problems with the installation? Let me know. And then the other thing is, so Jupyter Notebooks work through, also usually include something called magics, which is, in a Python script, you just write your Python code and you can do all of that inside this notebook. But you can also do other stuff. So for example, you can run shell calls from this. And so if I put an exclamation mark in front of the line of code, that means that line of code will be executed just in the terminal rather than inside a Python engine. So if I then type something like this, and run it, echo space, whatever, isn't actually a Python command, it's a shell command, which works on Mac and Linux. I don't know if it also works on Windows, but this just executes whatever you want to do in your shell. So obviously that's really cool for neuroimaging because a lot of the software that you might want to use is shell-based. So FSL is a shell application, and you can run all of your FSL calls from the Jupyter Notebook by just putting an exclamation mark in front. Yeah, so that's quite a nice way of combining different types of code inside a notebook. I've got, I think, I'll show you now how you would run a MATLAB notebook. So for that, what you first have to do is install the MATLAB kernel, and you probably want to, so you can just Google MATLAB kernel. It will take you to this GitHub repository and tell you how to install it. And if you follow these instructions, it will just install the MATLAB kernel. And if you also have MATLAB installed on your computer, you can then just run MATLAB notebook. So it's really easy to get set up. I don't know how many of you have MATLAB on the laptops, but that's what you would do. And you can then create a MATLAB example, create a MATLAB notebook, which I've already done ahead of time. And the cool thing about this is you've then got literal MATLAB code inside your notebook, so you don't have to know any Python to still be benefiting from using the Jupyter notebooks. And so, obviously this is MATLAB code rather than Python code, but it still renders nicely and puts your output here. And so this is just printing 1 to 20. And you can still use all the other cool stuff that Jupyter Notebooks provides. So you can still use the command line. And then the other cool thing is you've got, so I'll just restart the kernel. You've got plots that are rendered in line. And this takes a while because MATLAB is slow in doing graphics. But whenever you run a plot, it will just be shown in line. Obviously, sometimes you want the benefit of having interactive MATLAB visualizations. So what you can do is you can tell this, you can tell your kernel to produce a native MATLAB figure window, which you do by just adding this little magic line at the beginning of your window, at the beginning of your cell. And if you then run the same, it will open a MATLAB figure window. And you can then resize your image here or whatever.
It's a bit of a stupid question, but would you then literally write your entire code in that notebook, or do you literally do you use it as a notebook, as in you have certain pieces there and then you copy them into your code or whatever? Do you know what I mean?
I do, yeah. So you can do. I mean, what I would do is run the main components of your code inside the Jupyter notebook. And if you have functions or things like that, you can outsource them to different script files. And so you can, for example, in this gradients project that Richard has, we've got a couple of MATLAB files in here, if I can find them. So maybe we don't have them anymore.
There's a folder called method functions. If you look at that.
Oh, nice. And so you can have these MATLAB files in here, and you can actually edit them in here as well, which isn't quite as nice as editing them in MATLAB itself. But as long as you have the files here, you can then run a function call from your Jupyter notebook to these MATLAB files and have maybe more complex code, and you don't want all of that to be displayed inside your notebook. Just in any way you would run a MATLAB function from a MATLAB script. So going back to this, you can then, so I think particularly interesting for this is that you can then also combine it with different languages. So if I, at the beginning of a cell, say %% Python, that indicates to the kernel that it is supposed to run this code in Python. So if you do that, and you type Python code, and obviously this will give a syntax error in MATLAB, it will just run Python code and display everything that is output in much the same way as displaying the native MATLAB code here, the native MATLAB output. Yeah. So that's really useful. You can combine MATLAB and Python. And I think in particular, there's some issues around sharing workspaces. So obviously the variables that are inside your MATLAB aren't shared with a Python function call that you might be making. And so if I define a variable up here, I wouldn't be able to then use that variable down here. So if I say, and run that, I wouldn't then be able to say print test string. And so it gives me an error there. But I think the nice thing about a lot of the stuff you do in neuroimaging is a lot of the stuff, whenever you run a function call, it creates a new file. So if you, for example, do a pre-processing step in SPM, what you can do is you can save the result of that into a new Nifty file, and you don't actually have to keep your variables in memory. And so if you then use a function call from Python or from the command line, you can access the same data because it's stored in the file. So that's handy. And so I'll just show you how you do different things inside a, if you're doing a neuroimaging analysis. This is just a scan that I have on my computer. And if I run FSR view on that Nifty file, it will open an FSR window. You need to explore that data right here. So you can do all of that from inside the Jupyter notebook. And I close that. And then if I read that same Nifty file into a MATLAB function or into a MATLAB variable, which I'm doing here because I'm not, putting an exclamation mark in the beginning. So this is MATLAB code, and then I say, just show me a random slice from this image. It will do that, and because I told it to use native MATLAB windows earlier, it will do it in a native MATLAB figure window. So that's quite nice. And obviously, you can do this with any of your other imaging toolboxes as well. And then this doesn't actually work because I don't have an NiPy installed on this computer. But you could then also, do you could use the NiPy interface for SSL to run a smoothing step and output it to a Nifty file, and it will run that for you in Python. Save it to a file, and then you can use that file later on in a MATLAB code cell.
Yeah.
Yeah.
I'm really sorry. Why would you do that in a Python cell rather than just in a Jupyter cell? Is this where you want to mix between
Yeah, exactly.
Okay.
So I think that's quite handy about these kernels, that if if you're using different packages that come in different languages, you can combine them in the same file. And there's still a bit of limitation, so you can't just randomly pick a language. I wouldn't be able to run any R code inside this notebook because it runs inside a MATLAB kernel, and that MATLAB kernel only understands Python and MATLAB and the command line. So if I wanted to run R code, I'd have to actually open a new notebook with the R kernel, driving it. Yeah, so does that all make sense? Have people drunk the Kool-Aid and why these might be useful? I'll show you a different example as well in R. I don't know how many people use R here, but if you have, so at the top right, you can see that this is running in an R kernel, and this is again something I produced earlier. To run this, you need to install R and the R kernel. But once you have that, you can then run R code. So this is, code that would again produce errors in Python or MATLAB. If I run it, it loads ggplot and dplyr. And if I then run this code component in which I just want to display components of this data set empty class, and then maybe make a simple plot. I run that cell, and it produces quite nice output all in line. Yeah. So that's kind of the implementation of Jupyter Notebooks. People got it working on their computers now. Yeah, people tried making Python notebook. Yeah.
Which kernels are available on GitHub for running stuff?
Sorry?
Which kernels are available on GitHub for running the notebook?
So notebooks don't actually run on GitHub. No, they render on GitHub. So once you save this and push this to GitHub, you can then go to the website, go to the file on GitHub. So I have an example here of a notebook that I'm working on, and it renders, but it doesn't run. So this is for people to look at the notebook, and they've obviously got all the markdown stuff, and they have the code cells. So this is, this is a MATLAB notebook, and I'm doing a shell call here, and I'm using MATLAB here, and it all kind of renders nicely on GitHub. So once you've done your analysis, you put your output in line with your code, you can put it on GitHub and show people what it's like, but they're not able to interact with it yet. And so that brings me to my next point about sharing your notebooks. So you can obviously host your notebooks on GitHub, like I was just showing you, and then other people can clone the repository or download it, just as a raw notebook file, and then run it on their computers. So that's an easy way to just give people the code for them to do whatever they want with. Like I said, if people maybe aren't actually working on their computers to run this code right now, you might want to just send them a link to the GitHub page, and then they can look at it without having to run anything. And then the other cool thing is a website called mybinder.org, which is extremely handy in that you give mybinder a GitHub repository, and it seems to be running a bit slowly, but then it builds it, and you can then give people a link to your mybinder page, and they can actually run it online. These are people in Stanford maybe that are providing the service to actually run the code, so the code is run remotely, and you're not actually using any resources on your computer, and you don't need to install anything, so it's really handy for them to try it out. Yeah, so that's a nice way. I'll show you an example of where I did this with a collaborator of mine. I haven't looked at this in a long time, so it's like broken in the meantime. So it is very slow because they're obviously providing the server space for free and it takes a long time to run things. But it's really nice because you can just give people, you know, a link, and then that install has the Python installed. It has all the different packages and stuff that you need for it, and it just runs your code on the server. And there's really nice tutorials for neuroimaging, for example, and for NiPy that are running on Finder, and you can use those to, you know, just try out neuroimaging without having to install Python and NiPy and everything else. This isn't going to work. Sorry. But it is really nice. And the other thing is, so I'm actually at KCL in London, and I am currently working with them on getting like a kind of local implementation of something like this running on the KCL servers. So you can, it's called temporary notebooks, and whenever somebody visits your notebook, it kind of creates a temporary instance of Python, and you run the notebook inside that. And again, people don't need to install anything; they just do it through their web browser. They like close the window, it, you know, makes everything disappear. But it's nice for people to try out code. And I think in particular in teaching, I don't know how many people here do teaching, but I think it's really useful in that regard because you can give people the code to, so the opportunity to run these things without having to make them install something. And there's actually a cool Nature article, if I can find it. So there's a Nature article on interactive notebooks, and they ran this kind of temporary thing and for people to try it out. And so if you give people this link, you know, they can run everything that they want to inside this web browser. And this is not running on my computer. This is running on a server. So it's really handy to try it out. So I can create these graphs here. You can actually, yeah, you can also do interactive plots, which I think this will do. And so you can, you know, make these sliders for people to interact with your data. And Björn actually wrote a really nice little app. Do you have it running, Richard?
Yeah.
Do you want to maybe show it?
Control.
For, you know, browsing through your imaging files, which again I think is most useful for people here.
Okay.
So I'll just try and show you that on there.
No, it's not working.
Oh, okay. It is still under development, so a lot of things do kind of go wrong with this.
I'll show it after lunch.
But once you have it working, it's really nice. Yeah, and I think the other thing that these notebooks are really useful for is for tutorials. And so what I'm working on right now actually is a project where I'm trying to put a lot of neuroimaging tutorials that are out there already into Jupyter notebooks. And so this is one on receptive field mapping, just because I was trying to learn that anyway. So I was going through this tutorial that was in a PDF, and I thought it would be a lot nicer to have this as a Jupyter notebook. So I just kind of copied everything across and put the code into code cells. And then it's really nice because people can download this tutorial and run everything, including the documentation, on their computer, and you don't have to like alt tab between your MATLAB window and your PDF window and stuff. Yeah, that's another cool thing about Jupyter notebooks. Okay, so that's kind of my introduction to it. I don't know if I have anything else to add. Does anybody have any questions or still having issues with getting it set up?
Just wondering so if you kind of want to save your notebook, there I can see your icon to save it. Do you just click that and where does it save, or how's the best way?
So it says that, so once if you're in this folder, so in this view where you have your directory structure, if you say new, it will create it inside this folder.
Okay.
So the Python example where I click new inside this folder is not here now.
Okay, cool. And then whenever you open your notebook, it will take you to that top directory.
Yes, yeah. Well, it depends on where you open it in the terminal. So if you type Jupyter Notebook inside your root folder, then which I've done here, then it's got it inside your home folder, and then you can have the whole directory tree. If you just if you change directory in terminal to this folder, you only have that folder inside Jupyter Notebook. It's actually a way of preventing people from using this to kind of hack your computer, because it only accesses the directory that you started in.
Yeah. Can you show people in a the text you would want to do the notebook looks like if you don't
Yes.
if you don't have to do the notebook running?
Yeah. I can. So they are, I think it's JSON files they actually are underneath. So if you open it as a text file, it's got all this JSON code. I don't know if I can make this any bigger. And so it tells, in the beginning, it tells you, all the different cells. And so, like, it just says cell, and then it says cell type markdown, and that kind of tells Jupyter this isn't supposed to be a code cell that's run, it's supposed to be a markdown cell. And actually, I don't know if they're working on this, but I actually find it a bit annoying sometimes that when you're using version control for this, because it counts your executions. So like always, whenever you run something that has execution time 2, and if I run this again, it would say execution time 3. And if you're using version control, it always notices that change in the text and considers it a meaningful change to your document, which I don't know if it really should be. Sometimes I find that annoying.
I think this is also what got us messed up right now.
Yeah.
With version conflicts between my version and Rich's.
Yeah. Yeah. So I think this is still a relatively young project, and it's still kind of being worked out. But yeah, this is what it would look like if you didn't have Jupyter Notebook installed. And so you can actually edit this stuff. So if I wanted to, edit this without having Jupyter installed, just on a laptop where I don't happen to have it, you can just edit it in the text edit app. Yeah. And they're actually working on something called Jupyter Lab right now, which is a bit more like what you might be used to if you just use MATLAB as an application, which is a kind of combination of your code and a command line that shares the same workspace and a directory structure all in the same window, which I think will be useful as well, just because it's a bit more handy if you actually have a command line to debug it and stuff. Yeah. So it's quite exciting. It's a very useful tool. And I think it's the future. Any more questions? Yeah. Okay, do you have MATLAB installed? Which MATLAB version do you have? Okay. Okay. Yeah. They have recently improved it because MATLAB now actually provides a Python interface. Yeah, I don't know why that might be. Yeah. Yeah. Okay. Yeah, I'm not entirely sure. The other thing that you can do in MATLAB actually is you can open a MATLAB installation and you can tell it to share this MATLAB instance, and then when you then open the MATLAB kernel, it will kind of use that instance that's already existing. So you could try that. I will, yeah, it's a bit more complex. I can send you some instructions on Slack maybe. Yeah. But I mean, the other thing that's nice about this, I can show you one where I've used this for an EEG analysis I'm doing. And so I'm using a MATLAB-based EEG analysis toolkit, which always works much in the way a lot of neuroimaging stuff works, where whenever it does anything to a file, it saves a new file, which is quite nice because you can, if you've already created those files, you can jump in at a later point inside your notebook and run code there that just uses the files that were already created. And you've just got like each step in your analysis. So if I have a, this my pre-processing pipeline and I have a re-referencing step, I have that in a separate cell with a bit of documentation around it. So it's quite nice in that regard. And in particular for kind of linear pipelines that you use in there, and it's really useful. And the other thing is you can actually turn these into presentations as well. So this doesn't have it yet. So if you turn this into a slide view and present it, it just turns your all your cells into slides, and you can edit that a bit more to make like multiple cells into one slide. But it's quite nice to if you want to present your code at a workshop or something like this, it's really useful for that as well. Yeah. Anybody got any other questions or still needs help setting up? You can always come to me later as well if it's not working yet, and I can help you set it up. So yeah, I think that concludes my introduction to these methods.